Hi guys, this is my first video on just some basic A-Level Trig. We're just going to go through how to identify angles using a CAST diagram and the common values of trig identities. So most of you probably seen this before, a CAST diagram. So we have all, sine, tan, cos. So what this basically means is that any angle between 0 and 90 in the all quadrant would be positive. Going over to sine, only sine values would be positive. Going over to tan, only tan values would be positive. Cos values positive. But this doesn't mean you can't have a sine value in a tan quadrant. It just means that the sine value would be negative. So if we have a look at the common values of trig functions, if you ever interpreted a graph, you'd understand where these values come from. But if you recognize the sine and cos sections, they're just the opposite way around. And this is made clear by looking at a graph. I'm hoping to do a more detailed video about sine, cos, tan graphs in the future, but this is just a basic intro. And then if you have a look at the tan section, all it is the sine values over the cos values. So 0 divided by 1 would be 0. A half divided by 3, square root of 3 over 2 would be 1 over square root of 3. Square root of 2 over the square root of 2 would give you 1, and etc. And then 1 divided by 0 would be infinite. Okay, so using this this all sine, tan, cos quadrant to work out values of angles, I would say the most important things would be is that we always work from this horizontal line. So every value we ever interpreted would be from this line. So I'm going to do a simple one to start with, and that value we are going to do is sine 30. Yep. So if we were interpreting to this just from our values, we already know this would be a half. But if we do it in the all quadrant where it would be, so 30 degrees, yep. So that would be a half. Then by using this, we could quite easily work out the values of sine 150, sine 100, 210, and sine 330. Yep. And we do this by just, if we do the same thing in the sine quadrant, so we have 30. Yep, we do it here. We have another 30. So I'm just adding 30 to, I'm taking away 30 from 180, and I'm adding 30 to 180. And then the same thing in the cos quadrant. Yep. So the value in the all quadrant would still be sine 30, which is a half. As we move over to the sine quadrant, by taking 180, 30 away from 180, we are left with sine 150, yep? So that would be a half, just by symmetry. Yep. So by now moving into the tan quadrant, so remember we worked from the horizontal line, so we took away 30, and now we add 30, yeah? So we're still working in sine. So if we do sine 210, that would equal minus a half. Because by working in the tan quadrant, we are now no longer in a sine positive area. Sine can only be positive in the all and sine quadrant. So it would have to be minus a half. And that's the same thing in the cos quadrant. So if we're working with sine, so remember, we're working from the horizontal line. So that's 360 degrees. If we take 30 degrees away, that is 330. Yep. So that it would then also be minus a half as we were working in the cos quadrant. Yep, so that's just the basic idea of interpreting these all sine, tan, cos quadrants, and hopefully I'll do a few more examples later on of how exactly we use this while answering exam questions. Because I know most people would interpret by writing out the actual graphs. So this would be a sine graph, and then they would then interpret this to try and find angles. But if you use this, it's a much easier and much, I'd say, more quick and easy method to finding angles when you're working with more complex problems. And hopefully we will go through some more trig identities as well. Thank you.